Welcome back to my channel. In today's video, I will talk about one of the very famous data structure, linked list. By the end of the video, you will understand what is a linked list, what does a linked list in the code look like, linked list type and practical example of it. Let's get started. Note, before watching this video, I want you to forget everything you know about array. The reason is nowadays, array have been used too widely, so the knowledge about array is often too deeply engraved in your brain, so it will be difficult to absorb a strange and new concept like linked list. Now, imagine you are a debt collector. You are assigned to your boss to collect debt at 200 Lang Street, for example. But when you get to that place, the person in the house is not the person you are looking for. They said the person who used to live here have moved to 100 Bangkok. And when you get there, the person in the second house tells you they just bought this new house. The previous owner had left for 20 Khoi. You keep looking and eventually you find the house where the debtor is staying. So there's no more house to point to. All the houses you have passed from a data type gather into a linked list. A linked list is a data type where each element is a node, and each node will contain two types of information. The current node information tells you where to find the next node, and as the last node, it will give you the information that there are no more nodes left to visit. Now we can create the node instance. A node instance contains two things: the data of each cell and the next node. Another example of linked list is to imagine an alien alphabet. They only have 4 letters. First, they give us the letter A. The letter A will be contained in a node. Each node shows us what that letter looks like and shows us what the next letter is. But we don't know what is next, right? So we continue to ask the alien. They say the next letter is F. After F comes O. After O comes Z. At this point, they say it's the last letter. That's when the next value of the node is null. Okay, so now as long as we have the value of node A, we can access all the remaining letters. We can write down on the same line as follow. If you are thinking about the initialization of this linked list, it's actually equivalent to when we initialize an array. To help you visualize more easily, I will now take an example of the problem of finding a letter in a linked list. The first is that your input just needs to be the head of the linked list. Here's A. Then we initialize a variable called current node and initially assign it to head. Next, I will compare the data inside the current node and the data I need to find. If it is the value we are looking for, then we will return the corresponding node entity. Otherwise, we can go to the next node by reassigning current node equal to current node.next. And the loop will end when we have reached the last node, that is when the node equal to null. At this point, I hope you have a certain understanding of the linked list part. But a lot of people ask me why you don't use an array instead of a linked list. That leads us to the problem number 2. Problem number 2 is that I want to insert a letter G after the letter F. Well, you are probably familiar with array. We will find the position of the letter F, move on the element by 1 unit, assign the array at that position to the letter G, and that's it. What about a linked list? First, we still have to find the letter F. Then, instead of having to move everything like an array, we just need to assign the next node of G is tau. And we continue to attach the next node of F to the node G. So the process of inserting the letter G after the letter F is completed. The example I gave you is quite simple, but if you imagine there are sometimes millions of elements, moving so many elements like an array would be very laborious. As for linked list, we only need a few steps as above. Now let's see what type of linked lists there are and how to use them. Singly linked list is the basic type of linked list that you have been learning up to now. The second equal important thing is the doubly linked list. In this type, each node, instead of just having next, now has the third attribute, prep, that stands for previous. In this type, instead of the normal linked list, we can only go forward. With the doubly linked list, we can go backward with the prep property. Although the data initialization step will be more difficult now, it will give us more ways to control and work with the data. An example of doubly linked list is a music streamer on Spotify. A song can be accompanied by its predecessor and successor. There is also circular linked list. In this type of linked list, its characteristic is that there's no endpoint, which means that the next property of the last node will be the head at the same time. The advantage of this data type is that now from any node, we can go through the linked list and not depend on the first point like a normal linked list. The disadvantage of this style is that if it's not handled properly, your code can be easily fall into an endless loop. With all the linked list type we have just reviewed above, linked list can also be used to create a stack or queue. If you also want to understand stack and queue better, you can click on the corner of the screen. If there's no link, it means I haven't finished it yet. One last thing I want to say is, when working with linked list, many developers use recursion instead of loop. For example, the search algorithm above can be rewritten using recursion like this. If you also don't understand recursion, please wait for my next video. I promise I will explain the recursion in the simplest way. Okay, so we have gone through lots of new things. Do you notice that all the part of video connect to each other and form a linked list? And at the current node, the next of this session return null.